Hello, my name is Justin Allred. I am an actuary with Milliman, and I will be presenting with Sri Malapeti. He's our principal solution architect at MCG Health, and we're going to be talking about burden reduction and the use of NLP to provide assistive intelligence in documenting evidence-based guidelines. Go ahead and go to the next slide. So as I mentioned, I work for Milliman and I consult with MCG. This session is not super technical. It's very much about the application of NLP to a business problem. So before we get into that problem, I think a bit of context about MCG is appropriate. MCG has been around in some form since 1988, was established as the Milliman Care Guidelines. It was founded by physicians and actuaries to understand risk and how to better manage it and to help align clinical care with medical necessity. In 2012, MCG joined Hearst Health, which is where they are today. Next slide, please. So MCG at its core produces medical necessity guidelines based on peer-reviewed literature. The goal is to curate the best available evidence for what's appropriate across the entire arc of patient care. Our clinical editors analyze and classify peer-reviewed papers and research studies each year to develop the care guidelines in strict accordance with the principles of evidence-based medicine. To give you an idea of the scope, there's a few statistics from last year on the amount of research our editors did. So nearly 175,000 unique articles were reviewed, covering over 5,000 guidelines. Those 5,000 guidelines now include nearly 50,000 unique citations, of which more than 6,000 were added just in the last year. So it's very broad, very comprehensive in scope. Next slide, please. So in the age of AI and machine learning, why is the evidence found in medical literature so important? So when it comes to decisions about care and medical necessity, observational data simply is not enough. Observational data will always suffer from the problem of unmeasured factors, regardless of the algorithms used on the data. We need randomization to solve that problem. And randomized controlled trials are the gold standard. Again and again, results from well-done RCTs contradict practices supported by common sense and observation. This includes many cases where the data was clear and plentiful and the conclusions seemed obvious, but when randomization was applied to the treatments, the effects disappeared or reversed. I'm going to quote from an excellent paper on the subject that says, even the most sophisticated adjustment techniques, including artificial intelligence and machine learning, cannot adjust for unmeasured factors. The problem of unmeasured confounding in observational research is not resolved by larger data sources, which only increase the precision of biased and incorrect estimates of treatment effect. Next slide. So where does AI fit in? The goal at MCG is to use AI to augment our evidence, not replace it. We want to connect patient health records to the evidence-based guidelines, allowing human experts to work more efficiently and effectively. This ensures that decisions made are based on solid evidence while leveraging the power of modern machine learning to extract information in an automated way. So now I'm going to hand it over to Sri to give some background on the problem we're trying to solve.
Thank you, Justin. As Justin alluding to what AI and ML can bring to to solve the real life problems we have. So the biggest opportunity we have presenting ahead of us is that today many of our providers spend good amount of time combing the health record to provide clinical documentation, especially in the areas of utilization management and prior authorization, to document or to see a certain what is the relevant information to evidence criteria in the health record. They have to spend a good amount of time. It's like combing to the haystack to find a needle. So the goal of the current project we are undertook is to how best we could surface the relevant information when a clinician, when a UM staff or a prior auth staff documenting the evidence guidelines so that they can do their job effectively, efficiently. So that is the opportunity we have. That's what we explored to bring both the evidence-based criteria and AI, bring them together to help solve a problem we have in front of us. Now, as you see, the whole goal of this project was to reduce the burden for the providers. So as you also see, there are quite a few initiatives from CMS and DaVinci and other organizations spending good amount of time how we could help clinicians spend their time doing the care, not actually working with the systems, right? That is the goal. So as Justin alluded to, it is the AI. It's a mechanism to assist. It is not to replace the judgment provided by the clinicians. So based on some of the papers today, an average around 15 to 20 minutes are spent either in utilization review or in conducting the prior authorizations. Our aim is to use the uh, advancements in NLP, AI to see whether we can reduce the time where the UM staff and the prior staff are spending to research the information. So that is the goal of what we are trying to accomplish. Now, the use cases we are solving with this particular project is how best we can surface clinical context to the user within when they are using evidence-based criteria to provide clinical documentation. And also one of the key goal is to not disrupting their EHR workflow. We want them to be part of, still continue to whatever they are doing in EHR, then provide help them to document in efficient manner. The second use case we are trying to accomplish is that help make a decision whether help make a quick decision whether this particular requires inpatient treatment versus observation. That is basically the optimal level of care. The third one is help staff to efficiently document inpatient medical necessity reviews so that they can defend the denials and provide the accurate clinical documentation as much as possible. The last use case we are also trying to accomplish with this project is as MCG has evidence-based clinical criteria, how best we can assist the user with the information available in EHR to reason over so that they can understand they can understand and they can focus which information is relevant so that they can do their job in an efficient manner. So these are the four use cases we are trying to address with this particular problem. So now, as we are alluding to, as we are using AI, ML, NLP to bring relevant insights based on the information available in EHR. So there are, most of you are familiar, there are two kinds of data we have access to in the EHR. One comes in the structured form, another comes in the unstructured form. In the structured data, MCG already had done a good amount of work coming up with a clinical decision expression that can retrieve the concepts from EHR, from things like problems, vitals, observations, then can compute a clinical expression to help a UM staff or a prior auth staff to say whether is there a possibility of a particular criteria could be met. Now, what we have done with this particular project, use unstructured data. That is, it comes in the form of the notes. Mainly it is presented in any of these notes mentioned here, radiology impression notes or history and physical or discharge summaries or physician notes. The goal is to use these notes and retrieve the relevant information and use those concepts and see which of these notes are relevant to the relevant to the evidence-based criteria at hand. So that is the goal of this project, to bring the relevant insights based on both structured and unstructured data. Now, just to give a visual, this is our one of the existing product which is already in the marketplace, both in Cerner and Epic. You are seeing a screenshot from Cerner. As you see on the screen, on the left side, that's where you see MCG evidence-based criteria. On the right side, you see the information from EHR, the relevant clinical context that is retrieved pertaining to this particular guideline. As the user trying to do a clinical documentation against evidence-based criteria, it retrieves the relevant information and also helps the user that we have some data that helps to meet this criteria. Now we are in this particular project, we are extending this mechanism to apply and retrieve the similar clinical concepts from the unstructured nodes. Back to Justin.
Okay, thanks, Sri. For our first pass at this problem, we decided to focus on radiology notes specifically for a couple of reasons. So first, there's many clinical indications for which the relevant info you're looking for is only going to be found in the notes. So there's not a lot of overlap with our structured data elements that we already have. Second, radiology notes are generally some of the simplest type of notes. They're a little shorter. So we suspected we could get some higher accuracy starting there than if we went for something like an H&P note, which is much more comprehensive. So shown are a couple of examples of relevant indications we might be looking for in the notes. So there's complicated pleural effusions, e.g. empyema, exudative or loculated. And I'm going to screw up pronunciation here, but hepatobiliary imaging showing biliary dilation or evidence of etiology, stricture, stone, or previously placed stent. So I read through those to show that the things we're looking for are fairly complicated concepts. So there's sort of a modern NLP approach we were hoping would be able to help out. Go ahead and, yeah, we're on the right slide. So the project plan, we had as a data source 3,000 radiology narratives and impressions obtained during acute stays. And we wanted to make the model both multi-class and multi-label. And so I've seen different definitions of these terms, but what I mean is that there were 15 possible labels we could put on each note, which makes it a multi-class problem. And we allowed for individual notes to have more than one label, making it multi-label. Of our original 15 indications we looked at, we ended up with about 10 we felt comfortable with, as there were a few where we just did not have enough volume to get reasonable results out of them. So now our key target, like what we're trying to predict, is the relevance of the note for the reviewer. So if we think back to the complicated pleural effusion indication, we labeled a note as relevant if it would be useful for the reviewer to determine whether that indication was met or not. In other words, notes that are positive and those that are negative for pleural effusion are both included. From a use case point of view, we're looking at the reviewer who's trying to determine if a patient meets medical necessity for inpatient. And so our goal is to just surface notes to them that will be helpful. And we worked with John Snow Labs on this project, and all the labeling you'll see upcoming was done using their Annotation Lab software. Go ahead and go to the next slide. So there was, for data preparation, there was, of course, data preparation of extracting notes from our source data, but that's not interesting in this context. What's interesting is the data annotation and how we found it was arguably the most important part of the project to get it right. We worked with John Snow to develop annotation guidelines that the annotators would follow, and we found that we needed to make them very specific to get good accuracy. Ambiguity led to different interpretations by different annotators. And we found this because we did some early inter-annotator agreement measurements on the first 100 notes. And on the first pass, we found the agreement wasn't as high as we would like. So we were able to go back and fine tune those annotation guidelines and really tighten up and get the agreement to a very high level in the upper 90s percent. We initially labeled the document kind of like this image here, so that a label or multiple labels would be applied to the radiology note as a whole. Go ahead and go to the next slide. So for model building, we partnered with John Snow Labs on that using their Spark NLP software. The initial approaches were to use a classifier fine-tuned from one of the BERT derivatives that's specific to healthcare terminology. And we also tried an approach where we extracted concepts using a named entity recognition model. So your problems, tests, and treatments, and then fed those outputs into a classifier. The results from both models were pretty good, but we decided to go another direction after getting some early results, as I'll explain on the next slide. So we realized the model was a bit too black box for our liking, and we wanted an element of explainability. So we went back to the drawing board a bit, and we decided to change our labeling and modeling strategy. And we began labeling chunks or phrases in the document instead of whole documents. This approach has a number of benefits, the most obvious being that the resulting model can find chunks that match labels, so we could highlight to the user why the model identified the note as relevant. The second reason is scalability. So radiology notes do tend to be relatively short, so it's not too much of a problem. But later when we move to longer notes, it's beneficial to be able to split the document into smaller pieces for processing. And when you're looking for chunks, you can process those individually much easier. Go ahead and go to the next slide. So given this new labeling strategy, our final solution was effectively a custom named entity recognition model in which the tags were not tags like problem test treatment, they were the labels for the 15 indications we were interested in. We also added an assertion layer on top of that in the late stages of the project, where given the label, it predicts the context such as present, absent, or possible. And these assertions allow us a bit more flexibility in shaping the user experience. So we could very easily switch to a model that, for example, shows only notes we think will help meet an indication, as opposed to just relevancy, positive or negative. So if the label was there and an assertion of present, we might show it, whereas if it says absent, we might not show it. Next slide, please. And then finally, just a little bit about the results. So results were very strong for a few indications and reasonably strong for others. We had greater than 95% accuracy measured by F1 score on a handful, about 5, and then another 5 where we had greater than 90%. And we felt this was pretty good given the complicated nature of the indications, and we definitely felt it was strong enough to put in front of users. As you might expect, generally the more volume we had, the better the accuracy. So we're confident that as we expand out and scale this, we'll have strong accuracy across the board. And then one other note, so for this use case, we prefer a high precision over a high recall. So basically limiting the number of false positive, because especially early on as users are learning to trust it, it's much more obvious. A false positive is much more obvious than a false negative. So that's how we tuned it. We tuned it for a high precision over high recall. So now I'm going to give it back over to Sri, and he's going to talk about some lessons learned from the project.
Thank you, Justin. So as we embark this project, we learned quite a bit. There are a few areas where we think this could be applicable to anybody venturing into similar projects. So the one area we spend good amount of time is the stakeholder engagement. So especially it is, we felt that there are moments of the project where we have to involve certain people so that we can continue make progress. As you see, the stakeholders we involved in this project, from a sponsor to from DevOps, all of them are play a vital role. So any successful NLP or ML engagement heavily depends on data. Data can come from many different sources, so it is important that for us it was useful. We have we have access to the right folks to understand the data structure, shape, how it looks like. So that is one of the lessons learned for us. And also we working with Johnson Labs, working with our internal data science teams. So we have a good understanding of what it means to from a pure data science perspective. Then also among the stakeholders we have from the business product management uh, individuals who are responsible for how to make this use of this AI NLP more, making more relevant or provide value to the customer. So we have, they were checking it, we were involving them at every moment. Then we also had some clinicians on the group. That is important for us that they provided a different a clinical perspective in every step, in data gathering step, data cleansing, and using annotation and model evaluation. So that really played a crucial role for us. Sometimes even to make certain decisions, should we what is the criteria we should be using for annotation, what is the criteria we should be using to extract certain things. So that's the clinicians played a critical role. And also, as any data science projects needs a lot of compute resources, and along with that, when you deploy, you also need certain resources. So a good engagement with the sysops and devops really makes this project successful. So one of the lesson is that there are various key stakeholders who were able to utilize their expertise to make this program successful. The next second lessons learned for us is the key. We felt that defining the problem is key, in the sense that sometimes when you have a hammer and nail, and when you are hammer in the hand, everything looks like a nail. But the problem with that is that you may not be able to add value, but you may be able to say we have used NLP and ML and AI. So one thing for us is that we clearly articulated what is the question we are trying to answer with this approach. As Justin was indicated, our key question we are trying to answer for the user was, is this particular note has any relevance for this clinical criteria? That crystal clear articulation of a problem helped us to make certain decisions as we proceed further in either annotation or model building or model evaluation. So we felt the defining the problem is a key aspect of success. Then the success criteria, I mean, as Justin again alluded to, when do you stop, where do we focus with precision versus recall? So it will be good if we can understand what exactly we are doing, and if we can put that criteria ahead of time, that actually helped us. I hope it helps for others too. So next is the data. So I mean, data is the make or break for any ML engagement. In this case, again, we are able to get the relevant data so that we can annotate, train, model, and use it in application. So now, as the strategies wise, we use the real data. Along with that, wherever required, we were able to augment so that to add some variety to it. Now, with respect to the data, even though this data is actually coming from the customer, sometimes we found there are biases in the notes. It comes in many forms and shapes. The one interesting one we found was that there was a template used to document these notes. Now, model was picking up some of those things from the template. So it is important to spot check, cross check to see the data is not subjected to any of these biases. And also, as we pull the data required for this project, the correct sampling of both positive and negative data sets. Sometimes we had to augment for the negative data sets. So, and as we moved along the project, there were data surprises. Sometimes the population we used, the 15 indications, some of them have good amount of volume so that the model can learn. Some of them we didn't have enough volume, so we'll find the surprises. We found those surprises and we have to adjust accordingly. Then there is noise you see in the data. Sometimes you just only see one liners, and they could influence your both annotation as well as modeling. So we have to be mindful about that. And also sometimes the size, sometimes this could be crisp, sometimes could be lengthy. So these are the various data surprises we come across on this project. So then, as Justin said, we use the JSL annotation tool to label or and also classify whether the assertion is present or absent. One thing really helped for us is that coming to an agreement at the annotation life cycle in terms of how these notes will be imported, how they will be tagged, how they will be labeled, and how they will be communicated to the clinical subject matter expert to be reviewed and spot checked. So it was crucial for us to early stages of the project to spend good amount of time so that there won't be any biases creeped in. So another experiment really helped us is the inter-annotator agreement. So this one was we were able to give uh, same notes to all the annotators, and they independently annotate them and compare the results and see the biases and reason over the biases and agree so that we can minimize as much as possible. So that was very crucial. Then this another thing called watch for annotation fatigue, in the sense that as we try to annotate day in and day out, there is again some level somewhere our biases try to creep in once in a while. So it was important for us to put some spot checks in place to making sure we are the annotations are not subjected to any personal bias. So this was very crucial part of our this project. Then the agility, right? So as we have globally distributed teams, and also our people are working in a different time zones, it was important for us to have in constant communication using various mechanisms. It helped us to quickly respond to each other to make remove any impediments on our paths. And as I was mentioning, there were some surprises as we move along. We found some things, we were expecting something, we found some things in the data. And so according to that, we have to change the direction to accommodate the surprises as we encounter. And other thing, we were transparent in terms of the with respect to the data collection process, annotation. We were transparent across the board. And apart from that, as Justin also was indicated, as we try to train these models and put in front of the customers, we also played a um, we put a highly emphasis on the explainability part. So the last one is the feedback loop. It's not just a linear process. It's basically there could be anything, an API performance could, in our cases, API performance could lead us to make some changes in the model. Similarly, the model helps to change some changes in annotation. So it is a constant feedback loop that helps us to achieve the goal in whatever was in front of us. The final lessons learned in the areas of deployment. So once we have a model, it's good and it's giving the results what we were expecting to. Now we have to integrate with our application workflows so that they could be used by our customers in a business context. So now when we wanted to integrate, the issue is that sometimes model could be highly performant, highly accurate, but it may be taking a lot of time performance. So it is a trade-off between performance and accuracy. So we have to deal with that kind of an issue. And then we've mainly also spent good amount of time on the API contracts, making sure the API contracts provide enough information so that either application can turn and turn off some knobs with respect to confidence intervals, also the explainability part. Then the deployment, how what kind of infrastructure we wanted to use so that we can scale it for more number of users. The last piece still actually working into it is to how constantly monitoring the model and the runtime performance against the changing data drifts, to making sure how we are accommodating them in our model. So all in all, these the various lessons learned helps us to understand the nuances of executing an NLP project with a team which has multiple stakeholders. So with that, I will hand back to Justin.
Yep, and I think that's it. So I don't know if there's any time for questions, but that is the end of our talk. Thank you for joining.